Hey y'all. I've got a little camera here set up so that I can help you guys take some notes. One thing that we're going to be doing here is we're going to be working on solving equations. We're going to start out with one-step equations and then kind of progress throughout multi-step equations. So first thing that I want to talk about before we start doing our equations, the first thing that I want to talk about is inverse operations. Okay, so if you're taking notes or if you have some paper out, you feel free to write this down. Inverse operations, and this is something we've talked about in class before. Inverse operations are operations that undo one another. Okay, so operations that undo each other. Operations that undo each other. And you may consider these like opposites. Okay, for instance, if I were to add something, what would undo addition? Subtracting. Okay, if I were to multiply, what is something that would undo multiplication? In other words, what's its opposite? You should be thinking divide. If I square something, okay, that is to say raise it to the second power. We've talked about that. How do I undo that? In your head, you should be saying, take the square root. Take the square root. That undoes it. Okay, so you know about inverse operations. And today we're going to use inverse operations to solve equations. Again, this is not new, but it's been a very long time since we did this. So let's put on here, solving one-step equations. Hope you appreciate my document camera for all it's worth. I'm pretty proud of it. Let me move my camera down a ways so that we can see what we're doing here. Okay, so solving one-step equations. What that means is I should be able to solve the equation for x. In other words, isolate the variable in only one step. Okay, one step. So let's give an equation. Let's say x plus 4 equals 6. Okay. What I'm seeing here is an addition sign. That is the operation that I see. Okay, I'm seeing that something, 4, is being added to x in order to make the answer 6. Okay, so how do I undo that? Well, if I look back up here in my inverse operations, I can see that to undo adding, I should subtract. Okay, so we're going to move this 4 by subtracting. We're undoing the addition that's already happened. And the rule is, I've seen you do a Great Wall of China here. The rule is, what I do to one side of the equation, I must do to the other. Okay. I like to draw my equal sign or my baseline all the way across the equation. It just helps me with organization here. When I have plus 4 minus 4, those things cancel out. That was the whole point, right? Undo one another. I'm going to drop my x, bring it down. I'm going to bring down my equal sign. And now I have 6 minus 4, and that is 2. So at the end of the day, x equals 2. Final answer. Now how do I check that? Well, I could plug it back into the original equation in place of x. And if the math works, my answer's good. Let's try another one. Okay, let's try x minus 3 equals 8. X minus 3 equals 8. Okay, what's happening here? Well, we're subtracting 3. And if you'll remember from the very top, to undo subtracting, I should add. So we'll add 3 to both sides. Same thing, baseline all the way across. You can draw your Great Wall. That's fine. What happens with negative 3 plus 3 is they cancel out. They're gone. Drop my x. 8 plus 3 is 11. I could go ahead and plug that back in. Indeed, 11 minus 3 is 8. So I'm good to go. Final answer, x equals 11. Okay. Let's look at it. One more, actually 2 more. Let's get 2 more examples here. What happens if I see a number and a letter smooshed together side by side here? Let's dig a little deeper here. Let's say equals 64. Okay, equals 64. What if I see a number smooshed together with a letter with no sign in between? Okay, I've told you before that if they're mushed together right here and you don't see any sign in between, they look like they're stuck together with a magnet. That means multiply. Magnet means multiply. So if I go back up here to my rules, how do I undo multiply? Boom, divide. So we're going to divide both sides. Remember, what I do to one side, I must do to the other. Divide both sides by that number in front, also known as the coefficient. Okay, what happens when I have 2 divided by 2 is that makes 1. That's a whole. That's a whole. So we're going to drop our x. And on the other side, 64 divided by 2, 64 divided by 2, well, that's simple 32. And we're done. And I should be able to check my work by saying that 2 times, if I plug in the 32 in place of where x was, I should get 64 on both sides. And that's how I know I did it right. Okay. So again, when I have the same number on the top and the bottom of a fraction, that makes 1. In other words, 1x. And that's where I get to drop down the x. I only have 1x left. Okay. Last one. Last one. Let's get one more look over here. What if I have x divided by a number? What if I have x divided by a number? So again, we're looking at when I'm dividing, what's the inverse operation? Well, that is to multiply. So let's multiply by that 5 and see what happens. Okay, and again, what I do to one side, I must do to the other. When I multiply by this 5, I essentially made the same situation that I had over here, where I had a fraction with a top and bottom that are the same. It looks a little different, but really I've got a 5 on top and a 5 on bottom. And since those are the same number, that's that power 1 that I just talked about. That allows me to drop the x by itself, and now I've isolated the variable. Well, if I got 5 quarters, 25 times 5, I've got $1.25, otherwise known as 125. Okay. And I could do my same checking here. I could say, well, 125 divided by 5 should be 25. And if I can divide in my head, I can tell 25 is correct. Okay, so put a box around this guy. That's your answer.